ratio. Trigonometry ratio is using a right angle triangle and finding the ratio of the sides of right angle triangle. And before we start finding the ratio of the sides of a right angle triangle, we need to understand this. Don't forget, the sum of interior angles of a triangle is supplementary angles. When you add it up, you get 180 degree. Since right angle triangle is having one of its interior angles as 90 degree, so it means that adding the sum of the other interior angles, you get right angle, which is 90 degree. So which means that when you add alpha plus beta as shown plus 90 degree, you get your 180 degree. Then your alpha plus beta will give us 180 degree minus 90 degree, and that is 90 degree. So the sum of the other interior angles will give you right angle, which is 90 degree. And we have alpha will give us 90 degree minus beta, and beta is also 90 degree minus alpha. So when you know one out of this angle, you can find the other one within few seconds. So which means if this one is 30 degree, this one will be 90 degree minus 30 degree, and that is 60 degree. So if this is 45 degree, this will be 90 degree minus 45 degree, and that is 45 degree as well. Let's say for instance you have this triangle and you want to find this angle here. Since this is a right angle triangle, this angle here will be 90 degree minus 34 degree, and that is 56 degree. Note, this is only applicable to right angle triangle, so you can use this for right angle triangle, right angle scaling triangle. That is how to quickly find the third interior angles for right angle triangle. Now we have a right angle triangle with angle here as alpha and angle here as beta, and we label the side A, B, C. Now looking at this triangle, we have this side here, which is C, is opposite to this right angle, so which means that this C is known as hypotenuse. The other side will not have a name, and you can name the other side by choosing either you choose your alpha to name the other side, or you choose your beta to name the other side. So by choosing your alpha, it means that this A here will be opposite and this B here will be adjacent. And while choosing your beta to name the other side, this B here will be opposite and this will be adjacent. Now let's start fixing our trig ratio. The first trig ratio we will choose is sine. Don't forget your sine is opposite over hypotenuse. Now we are starting with our alpha. So we have, if we choose alpha to name this side becomes opposite and this side becomes adjacent. So we have sine alpha will give us opposite over hypotenuse. And what is opposite here? Opposite is A and hypotenuse is C. So we have A over C. Now cos alpha is also adjacent over hypotenuse. So cos alpha will be B over C. The same thing goes with tan alpha. Tan alpha will be A over B. Just go ahead and look at your triangle to fix that. Now we have the inverse form of all these trig ratio. The first one is cosecant. The inverse of sine is called cosecant, and the short form of cosecant is cosec. Cosec alpha will be inverse of sine alpha, which is C over A. Go ahead and look at this. This is A over C, and this is going to be C over A. And the inverse form of cosine is called secant, and the short form is sec. Sec alpha will be the inverse of cos alpha, and that is C over B. Now to the inverse of tangent is known as cotangent, and cotangent alpha is b over a, the inverse of a over b. Now we're done with alpha, so let's fix our beta. Now choosing beta, this side becomes opposite and this side becomes adjacent. Now we have sine beta will give us b over c, cos beta will give us a over c, and tan beta will give us b over a. The same thing goes with the inverse. The inverse of sine beta, which is cosec beta, will give us c over b. Sec beta will give us c over a, and cot beta will give us a over b. A popular name that we use for remembering all these trig ratio. Now for the normal trig ratio that we are familiar with, which is sine, cosine, and tangent. So we have SOH CAH TOA. Why? SOH means sine is equals to opposite over hypotenuse. Cosine, which is CAH means adjacent over hypotenuse. And TOA, which means tan, and tan is opposite over adjacent. Now there is another one which is meant for the inverse of this trig ratio, which is quite funny, which looks like Chinese name, which is SOH CAH. SOH CAH is the inverse of SOH CAH TOA. While your cho means cosec is hypotenuse over opposite, sha means second is hypotenuse over adjacent, and cow means cotangent is adjacent over opposite. So you can use this to remember your trig ratio. Just master SOH CAH TOA and SOH CAH. Now let's find the relationship between all these trig ratio. The first one is we have sine alpha is still the same as cos beta. We have sine beta still the same as cos alpha. We have tan alpha is the inverse of tan beta. And we have cosec alpha is still the same thing as sec beta. And we have sec alpha still the same thing as cosec beta. And we have cot alpha is still the same thing as the inverse of cot beta. Now we have tan alpha still the same thing as cot beta. Now recall that alpha is equals to 90 degree minus beta, and beta is equals to 90 degree minus alpha. And substituting that into this, what we have here, so what are we going to have? We have sine alpha give us cos 90 degree minus alpha. So which means that sine 20 degree will still be the same thing as cos 90 degree minus 20 degree, and that is 70 degree. So when you have two pairs of angles that are complementary angles, sine of one will be the same as cosine of the other one. So which means sine 30 degree will still be the same as cos 60 degree. Sine 10 degree will still be the same thing as cos 80 degree. Cos 15 degree will still be the same thing as sine 75 degree. Now the same thing goes with cosec alpha. Cosec alpha is still the same as sec 90 degree minus alpha, and sec beta will still be the same as cosec 90 degree minus beta. So now to the tan. Now tan alpha will still be the same as the inverse of tan 90 degree minus alpha. So which means that tan 20 degree will still be the same as 1 over tan 90 minus 20, and that is tan 70 degree. Two pairs of angles that are complementary angles. Tan of one will be the same as the inverse of tan of the other. So which means that tan 30 degree will still be the same as 1 over tan 60 degrees. Finally, so tan beta is also what? 1 over tan 90 degrees minus beta. And the same thing applies with cotangent. So cot alpha will still be the same as 1 over cot 90 degrees minus alpha. What is the value of sine 60 degrees using cosine? Sine 60 degrees will still be the same as sine 60 degrees will still be the same as cos 90 degrees minus 60 degrees, and that is cos 30 degrees. Sine 45 will still be the same as cos 90 degrees minus 45 degrees, and that is 45 degrees. Now let's have a proper examples to see what we have learned in trig ratio. The first example is if tan theta is equals to 3 over 4 for 0 less than theta less than 90 degrees, find I 2 cos theta plus cot theta, I cosec square theta plus sec square theta, and I 2 plus 5 tan cube theta over sine square theta. Now to solve this, we have to find all these expressions, and the first thing to do is you have your right angle triangle and you represent this trig ratio using your right angle triangle. Here we are given tan theta, and that is 3 over 4. So we have our right angle triangle. Now the next thing is we have to represent our theta, so that you choose this angle or you choose this angle. So I choose this angle as theta. And what is tan? Tan is opposite over adjacent. So we have here our opposite angle is this side. Opposite side to this angle is this side, so which is 3, and the adjacent is this side, which is 4. Now we need to find our hypotenuse. Now to find our hypotenuse, now we use Pythagoras theorem to find our hypotenuse. Using Pythagoras theorem, we have hypotenuse square is equals to opposite square this side or adjacent square plus the opposite square, the sum of the square of the two other sides. So we have 4 square plus 3 square. And what is 4 square? 16. What is 3 square? We have 9. Then we have 16 plus 9 is equals to 25. Now we have our hypotenuse will give us square root of 25, and that is 5. So we can fix our hypotenuse. Hypotenuse is 5. The next thing is to start finding all these trig ratio. The first one is let's find our sine theta. Sine theta is opposite over hypotenuse. So we have our opposite as 3, hypotenuse as 5. We have 3 over 5. Now we have cos theta. Here will be adjacent over hypotenuse. That is 4 over 5. The next one is cosec theta. Cosec is the inverse form of sine. So we can find the inverse of sine, and that is 5 over 3. Now we have sec is the inverse of cosine, and that is 5 over 4. Now we have cot theta is the inverse of tan, and that is 4 over 3. Now we have sine square theta. Sine square theta is sine theta multiplied by sine theta. So our sine theta is 3 over 5. Then we find the square, which is 3 over 5 multiplied by 3 over 5. And that is 3 over 5 square, and we have 9 over 25. 3 square is 9 and 5 square is 25. We have cosec square theta is cosec theta square, and that is 5 over 3 square, and that is 25 over 9. The next is sec square theta, and sec square theta is 5 over 4 square, and that is 25 over 16. And we also have tan square theta. Tan square theta is 3 over 4 square, and that is 9 over 16. And we have tan cube theta, which is 3 over 4 cube, and that is 27 over 64. 3 cube is 3 multiplied by 3 multiplied by 3, and that is 27. And 4 cube is 4 times 4 times 4, and that is 64. Now these are the trig expression that we've gotten. And let's start solving our question. The first one is 2 cos theta plus cot theta, and that is 2. We have our cos theta here, which is 4 over 5. And we have our cot theta here, which is plus 4 over 3. Now let's expand this. We are going to have 8 over 5 plus 4 over 3. And what is the LCM of 5 and 3? And that is 15. Now you have 15 divided by 5, you have 3. 3 multiplied by 8, you have 24. Plus, now 15 divided by 3, you have 5. 5 multiplied by 4, you have 20. And you have 24 plus 20, you have your 44 over 15. And you cannot reduce this fraction. Why? 44 and 15 do not share common factor, so your final answer will be 44 over 15. Now we have the second question, which is sec square theta minus tan square theta. And what is the value of sec square theta? Sec square theta is 25 over 16 here. And tan square theta is 9 over 16. And we subtract it. Now they have common denominator, so you have your denominator as 16, then you can subtract the numerator, and you have 25 minus 9, and that will give you 16. 16 divided by 16, and you get 1. Now to the third question, we have 2 plus 16 tan cube theta over sine square theta. Now you have your 2, you have your 16. What is tan cube theta? Tan cube theta is 27 over 64 here. And your sine square theta is 9 over 25. Now you have 2 plus, what is 16 divided by 64 divided by 16? You have 4. So that is why you have 27 over 4 here. Now, what is 2 plus 27 over 4? You turn this 2 to fraction, and by dividing it by 1, so you have 2 over 1 plus 27 over 4 divided by 9 over 25. Now, what is the LCM of 1 and 4, which is 4? 4 divided by 1, you have 4. 4 multiplied by 2 here, you have your 8 plus 4 divided by 4, you have 1. 1 multiplied by 27, you have your 27. Now you have 8 plus 27, that is 35 over 4 divided by 9 over 25. And that is what we have here. Turn this division sign to multiplication sign by finding the inverse of this 9 over 25. So we have 35 over 4 multiplied by 25 over 9. And when you do that, you have 35 multiplied by 25 over 4 multiplied by 9. 35 multiplied by 25 is 8, 75, and 4 multiplied by 9 is 36. Now 8, 75, and 36 do not have common factors, so this is our final answer. Now look at how we solve this question using trig ratio. Now, when solving this question, the first thing is to have your right angle triangle and fix the trig ratio. Find the third side and go ahead and find other trig ratio in the question, and you go ahead and solve your question. And here is another example, and let's see how to solve this question. And find 2 sec theta if cot theta is equals to t plus 1 for 0 is less than theta less than 90 degrees. Now let's see how to solve this question. The first thing is you have your right angle triangle and you represent your trig ratio. Here in the question we are given cot theta as t plus 1. Now the question is, how do we fix the other side? Since we are given t plus 1, now we can apply fraction, and you can convert any whole number to fraction by dividing the number by 1. Here we have t plus 1, and you can convert it to fraction by dividing it by 1. So instead of having cot theta is equals to t plus 1, we can have cot theta is equals to t plus 1 divided by 1. Now we can use that to fix cot theta. Now we have our angle here as theta, Now, what is cot? Cot is the inverse of tan, and cot is adjacent over opposite. Now here we have to fix our adjacent, and our adjacent is t plus 1. Then our opposite will be 1. Now we need to find the hypotenuse. Now using Pythagoras theorem, we can find our hypotenuse. And how do we find our hypotenuse? Finding it using Pythagoras theorem. So we have hypotenuse square is equals to square sum of the square of the other side. So we have our t plus 1 square plus 1 square, and t plus 1 square is equals to t plus 1 multiplied by t plus 1. Then what is 1 square? We have 1 here. Now t plus 1 square is, we are going to expand this, and expanding it, we have t multiplied by t here, we have t squared. In t multiplied by 1, we have t plus t, and 1 multiplied by t, we have another plus t, and now we have 2t. Then 1 multiplied by 1, we have 1, so we have t squared plus 2t plus 1 plus 1. And what is 1 plus 1? We have 2, so expansion of this will be what? T squared plus 2t plus 2. Now this is our hypotenuse. Hypotenuse will now be square root of t squared plus 2t plus 2. Now, to solving our question, what is sec theta? Sec theta is hypotenuse over adjacent, and let's fix that. Now, we have, what is hypotenuse? Here we have square root of t squared plus 2t plus 2. Then our adjacent is t plus 1. Now 2 sec theta will now give us 2 multiplied by square root of t squared plus 2t plus 2, then divided by t plus 1. Now we've solved our question. Now let's look at another question, and let's see how to solve that question as well. Find the value of the unknown angles and side in a triangle shown. Now observe this triangle. We have triangle ABD, and we have 3 triangles here. We have triangle ABC, we also have triangle ABD, and we have triangle ACD. Now using this triangle here, we can find the value of x. Now remember that we have a right angle here, so x will give us 90 degrees minus 30 degrees since we have a right angle triangle here. So x will be 60 degrees. Now using triangle ACD, we can find the value of y. And what will be the value of y? And your y will be what? 90 degrees minus this angle here, which is 60 degrees, and that is 30 degrees. Now using triangle ABD, which is a right angle triangle as well, we can find the value of k using trigonometry ratio. Now which ratio are we going to use? You can choose any ratio that is convenient for you. Observing your triangle, you can choose a perfect ratio that will fit and find the unknown angle. Here I'm going to choose sine. Now choosing sine, then I'm going to choose either 30 degrees or 60 degrees. So if I choose sine and I choose 60 degrees, now k will be opposite to 60 degrees. So if I choose sine and choose 30 degrees, L will be opposite to 30 degrees. Automatically, this 4 cm side BD will be the hypotenuse since it is facing this right angle here. So I'm choosing 60 degrees. Now choosing 60 degrees, I have sine theta will be what? Opposite over hypotenuse, and my opposite is k over hypotenuse is 4. So we have sine 60 degrees will be what? K over 4, and I can cross multiply, and I can cross multiply. Doing cross multiplication, so I'm going to have k is equals to 4 sine 60 degrees. And what is the value of sine 60 degrees? Pressing your calculator, so we have sine 60 degrees is equals to 0.8660. So we have 4 multiplied by 0.8660, 0.8660, and that is 3.46 centimeter. Finding the value of L, so I'm going to stick with sine. Now using this 30 degree over here, using sine, L will be my opposite. So using sine, so I have sine 30 degree will give me L over 4, which is opposite over hypotenuse, and that will be L, then cross multiply, so I have L is equals to 4 sine 30 degree. Then what is the value of sine 30 degree? Sine 30 degree is 0.5, so I have L is equals to 4 multiplied by 0.5, and that is 2 centimeter. Now I've gotten K, L. Now I want to find the value of M. Finding the value of M, I'll still use sine 30 degree. Now using this triangle here, which is triangle ABC, now AB becomes the hypotenuse since it is facing this right angle here. Now using this 30 degree, AC will be my opposite. So I have sine 30 degree will be what? M, which is opposite, over hypotenuse, which is K. And my K is 3.46. So doing cross multiplication, so I'm going to have M is equals to 3.46 multiplied by sine 30 degree. And what is sine 30 degree? Sine 30 degree is 0.5. So I have 3.46 multiplied by 0.5, and that is 1.73 centimeter. So that is the value of M. Finally, to find the value of N, I'm going to use this triangle here, triangle ACD. And using this triangle ACD, so I'm going to use sine 30 degree because this angle here is 30 degree. Now using sine 30 degree, which is the value of this angle here. Now using it, so sine 30 degree will be what? Opposite over hypotenuse. And what is my opposite? Opposite is this N. Hypotenuse is this L. So I have sine 30 degree will be what? N over, what is L here? 2. So I have N over 2. And when I cross multiply, N will be what? 2 sine 30 degree, and that is 2 multiplied by 0.5, and that is 1 centimeter. Now I've solved this question using trig ratio. In solving question using trig ratio, observe your triangle, choose an angle, name the sides, choose correct trig ratio that's aligned with the side that you want to find. Then you solve your question. Now, when are you going to use trig ratio? Now, using trig ratio, you can apply trig ratio when you have a right angle triangle and you know just one side of your right angle triangle, and you know at least one interior angles apart from your right angle. So that is when to use trig ratio. And to use Pythagoras theorem, you must know at least two sides of your right angle triangle. Then you can go ahead and use your Pythagoras theorem to find the third side of that triangle. Now this question can as well be solved using trig ratio and Pythagoras theorem. You can employ the two methods and use it to find the unknown side in this triangle. Let's say, for instance, I haven't gotten the value of K yet. The first solution, now we know the value of K and we know the value of this BD. So we can find L using Pythagoras theorem. We will still get the same answer. So that is how to use Pythagoras theorem and trigonometry ratio. If this is your first time of coming across my channel, kindly subscribe to this channel, click on the notification icon to get notified when I release video like this. Now this is getting more interesting as these are the foundation and the fundamental things you have to understand in learning trigonometry, and these are just the basics. Now watch out for my next video, which is going to be how to find sine, cosine and tangent of different angles using just your graph. So we are going to have a circle, then we are going to see how to apply that circle to find sine, cosine, tangent of different angles. If you want to learn mathematics, physics and chemistry, you can subscribe to this channel. Check out my various playlists, the first one being matrix. You can check out matrix playlist, check out mechanics playlist, check out Euclidean geometry playlist, check out circle geometry playlist, and even watch my random videos which is on heat energy. Now thank you for watching this video. See you in the next video. Stay blessed and bye for now.